The one thing he didn't mention is it's actually my birthday today as well. So I, and so my parents are also dialed into the live stream watching me, so it's very nervous right now. But I get to talk about my favorite topic at LinkedIn these days, which is metadata. And so that makes it a double celebration for sure. All right, so before we get started on metadata, let me quickly tell you what LinkedIn is about. I'm sure you know what LinkedIn is and what it does, but our vision is always not clear to everyone. So I think it's good to kind of reiterate it to everyone that we dream about creating economic opportunity for every member of the global workforce. And what that means really is operationalizing that vision or operationalizing the mission to make our members more productive and more useful is mapping the digital, the human graph into the digital world. So we've got 645 million members. We've got a lot of companies. We've got a lot of jobs, a lot of schools, and a lot of skills. And what we've been doing all this time is connecting all of these things into what we call the economic graph. And our mission really is to make this graph work for people. All right, so what happens behind that graph? What happens behind that graph is LinkedIn is running systems that are doing things to make LinkedIn.com work. And that looks like a standard microservices architecture. There are services at the top. We end up writing most of our code in Java. So these services are creating data, which is being written to databases. They tend to be a variety of databases we choose over time. We've built NoSQL stores, as well as we have some relational. And these database changes are streamed into Kafka. And so a lot of our change data comes into Kafka. And the services themselves are also emitting events like someone viewed a profile or someone liked something. Those kind of business events are also getting streamed straight into Kafka. And this data then flows into Hadoop, and that kind of combined ecosystem of Kafka and HDFS or Hadoop is our data lake, if you will, or our data warehouse, where we're doing a lot of standardizing of data, analytics, reporting, ML, all of that happens there. And then finally, this derived data is being brought back to back these services in the form of derived data sets. And these derived data sets could, of course, be features or models or just transformed data that is optimized, say, in a search index or in a graph index. And a lot of these services are then using these optimized data stores to render experiences back on the mobile client or on the desktop. And funnily enough, we have a lot of internal applications that we build for data scientists to be productive or for execs to get their reports and things like that. And all of those are also built on a very similar stack. So we end up kind of eating our own dog food in how we build LinkedIn.com, as well as in how we build apps for internal consumption. So that's kind of a very quick tour of LinkedIn's data ecosystem. But this talk is about metadata. And when we started, our metadata consciousness, so to speak, can only be described as being very young, almost like a little baby, now that I think back to those early days. And the questions we had about metadata were, of course, like, what is metadata, right? And when you look at Wikipedia or any of these other places, it's always described as data about data, but that's so meta that you always have to concretize it to say, okay, but what is it really, and what do I care about right now? And so when we started, the things we cared about when we were asking this question around metadata was strictly focused around what we had in our data warehouse. So that was a combination of Hadoop and Teradata. And we were asking this question, what data sets do we have there? How do we easily find them? What does their schema look like? And these data sets are deriving from one data set. You create one or many more. So what data sets derive from these data sets? And that's kind of the lineage problem. So that's what we started with. It's not a bad place to start. I think a lot of companies are still there. And this is what we built. So the architecture was pretty simple. A small team of 2 or 3 engineers went off, and they figured out what all catalogs we had. So we had the Hive Metastore. We were actually using HDFS in a raw form as well, so we had to go crawl some HDFS to figure out what data sets were in there. Then there was Teradata, and that at least had a JDBC connector, so you kind of figure out what tables were in there. And then you go after the log files. So we ETL'd a bunch of information from the log files to figure out what kind of transformations were happening. And all of that data got ETL'd into basically a database which served lookups. And then we wanted to build search, so we had a search index. And then we built an app on top. So that was kind of our attempt one, what I'm calling crawl phase for metadata. And to recap, the recipe looks like this. Crawl all the catalogs you can, parse all the logs you can, ETL into an opinionated data model, and that's kind of important because you have to have an understanding or an opinion about what a job is, what a data set is, and things like that. And then build a search index and a lookup store, and build an app to serve this info, make it useful. And it is a useful product. We actually built it. We gave it a clever name. We called it Warehouse because it was about the where and the how of data. And the data warehouse team actually forked off 2 engineers to go build it, so it made double sense. We open sourced it in 2016. And the name, it stuck, but it also was a constant source of problems because we would be in hallways and talk about, so who's working on the warehouse these days? And people would be confused. So it was too clever. My fault. So this is attempt one, so this is not the end of the story. We observed a few things that were problematic with this story. And it can only be described using this picture where the team that was doing all of this work felt like it was in a constant tug of war with everyone else. And a lot of it was because of the integrations were pull-based. You're getting into people's private stuff, right? You're parsing their logs, looking at stuff that are going to break tomorrow. And so you end up building really fragile pipelines. And so maybe you got it right this quarter, and you call it done. And then the next quarter, oh, the Informatica processing thing is broken, and now we don't have Lineage anymore. So that was one problem. The other thing was we couldn't get to kind of the stream-first ecosystem that LinkedIn has had for a while. So a lot of this were batch files that we were having to crawl. So that led to freshness issues. And the other thing is this opinionated data model makes it very hard to iterate quickly. The team, anytime someone said, oh, can I also get this other kind of metadata, the team would have to go figure out where to get it, kind of re-architect all of the database. And it just took them quite a long time to surface it back up in the app. Meanwhile, our metadata consciousness itself had gone through a little bit of an evolution. It was now a young teenager, I can call it that. And we were asking deeper and broader questions. So the questions we were asking was not just limited to the warehouse anymore. It was actually broader. And we were asking, what data sets do we have in our entire data ecosystem? Because we want to manage them consistently. We want to have compliance that works across everything in a unified way. And so some of the questions were similar, like what does their schema look like? How does data derivations happen? But some were deeper questions within those systems, like what are the business types that are contained in these schemas? So don't just tell me there's an int or a long in here. Tell me if it's a user identifier, things like that. And then we started realizing that data set ownership is a problem, or rather, not knowing who owns a data set is a pretty big problem, because when you find an issue with a data set, you don't know who to go talk to fix it. And especially if you're building something that has some regulatory teeth to it, you want to get really good at these things. And then finally, we were also wanting to get better at understanding how data gets copied across different systems. So these were kind of deeper questions that we had. And what we realized was that our initial model was not really scaling very well, as I had described. So we went from kind of this architecture to kind of a rev of this architecture, to adding in what I would call just a little bit of data integration 101 to the mix. So we said, let's make producers responsible for their data. So we created an interface using a Kafka stream, and we said, this is the metadata change event, and you must publish this change event whenever things change in your ecosystem. So we had the Hadoop team go and kind of figure out how they were going to crawl their data or metadata and then produce these events. We had similar agreements with other teams, and that culture change kind of helped. It's very similar to a culture change you go about with data, where you start decoupling producers of data and consumers and establishing clear contracts. So we did that, and then the team could focus on just having a standard ETL of that data into both the lookups DB and the search index. And then we also built a little service on top of this, because that decoupled the app. We had a monolithic app, and so we pulled out a different service. That service allowed clients to consume metadata without having to depend on the app to evolve to surface all of the metadata. So those are, I would say, they seem simple, but when you're a small team building things, you build it fast. And so we did attempt 1 and then moved on to attempt 2. At this point, the team had grown to, I would say, 7, 8 people at that point. And they were doing a lot of more things. So they were supporting this service that supports all of this diversity. We had to find names for every single data set, so we did some URN-based naming. We had to create a generic schema model that worked for all kinds of data stores, including blob stores and NoSQL stores and search indexes. So that was interesting. And then we did extensions to the data model, as I described. And finally, applied scalable integration patterns. So these were kind of the 3 things we did. And the big thing that also emerged during this was some people wanted to write using REST calls directly, and some people wanted to just publish a message. So we supported both options. So that was attempt 2. And we called it the stuff in the gray box, basically. We called it TMS, or the metadata store. We were hoping that the company wouldn't build another one, because we were tired of having lots of different metadata stores. And we said, this is the last one we're going to build, and so we're going to call it the metadata store. However, we noticed that a lot of these concepts were so LinkedIn specific, and the way we had built this thing, we couldn't open source it anymore. So even though we had open sourced Warehouse earlier, now the evolution of Warehouse, the back end of Warehouse, was kind of closed source, and that was not great. I mean, we were not happy about it, but that's kind of how the evolution happened. So that was attempt 2. And a few things we observed was that teams were now accountable for the quality of metadata they were producing and for their custom ETL. We were able to quickly aggregate a lot of base metadata from all of our teams and then apply new metadata on top very easily. So that was nice. So I could add a compliance schema or a compliance metadata aspect on top of all of our data sets without having to do a lot of additional work. However, the not so good was that you still were dependent on the central team, the TMS team, to evolve the metadata model. So every time you needed a new thing added to the metadata change event, which was now starting to look like a pretty large event, you would have to get in line. They would kind of figure out if this made sense or not, and then add it. The other thing we noticed, and I don't know if people have these debates in companies as well, other companies, but source of truth versus not source of truth, or what we were calling reflection of truth. So if you're a service that is actually responsible for writing the metadata, so you own it, you're actually the source of truth for metadata, then there's a lot more reasons why other teams will actually use it. But if you're just downstream of the real source of truth for metadata, then a lot of teams go, well, I guess I could call you, but you're going to be maybe a few milliseconds late or something like that, so maybe I'll get like the real fresh data from the source of truth. And so there were a lot of discussions where teams were not really taking a lot of dependencies on the service. The app was useful, but a lot of teams were not taking dependencies on the service. And that made us feel like, OK, we built this service. It's got a ton of good metadata in it. It's aggregating it all in one single place. Why do teams not use it? Well, because people want to connect to the source of truth. And the final thing we noticed was that this standardized event as an interface, it's good at decoupling producers from consumers. So that was working. But it wasn't really enabling producers to truly excel. And by that I mean that when an ecosystem like our online ecosystem with Espresso and Kafka, let's say they introduced a new kind of metadata in their ecosystem, they didn't have a lot of incentive to say, hey, metadata team, you might want to expand your model to also include this metadata. It was all driven by if a consumer wanted it. So not so much driven by a producer creating new metadata. So we were always somewhat lagging in understanding the full richness of the metadata ecosystem. So that was another problem. Meanwhile, our teenager had grown quite old. At least we felt really old and tired, asking this question again and again around what is metadata? And we knew that there were things about metadata that were important, like data sets were important. They were kind of important things. They needed to have names, they needed to have schemas, they needed to have owners. But these owners were people. And so we needed to know who these people were, what department did they work in, and what dashboards did they produce this week. And these dashboards were interesting as well. We wanted to understand what names they had and what charts were in them and what metrics were being plotted on those dashboards. And those metrics were important as well. They had names, they had granularity, like is it an hourly metric or a daily metric? And the metrics themselves were queries on data sets, and they had owners who were people. And so, it's a graph, and there's more. The AI world was producing models and features, and all of that had relationships with every other thing. And so we were realizing that this problem is not just building a single metadata thing for a thing, but it's actually understanding and representing the entirety of the metadata graph. And it's so similar to LinkedIn trying to map the entire economic graph. So it was kind of a meta observation in some sense. And some observations about this problem that we had was that there is value in local subgraphs. There will be value in having a metadata service that has a data set and its schema, and that's your schema registry, right? And a different metadata service that only stores ACLs for data sets. But the real value is in the global model, right? That's when I can truly do data ecosystem management. I can do a ton of things around productivity as well as governance. And the other thing we noticed based on our experience with building LinkedIn was you cannot execute on this kind of a extremely large graph model with a single monolithic team or a single monolithic model plus a service, because different teams were coming up with different ideas for what to model, and so they care about sort of different subgraphs. And a central team will always be a bottleneck with that. And if we just did microservices, you're back to the siloed metadata problem, where everyone has modeled metadata in their own little silos. They have their own DBs. You have no idea what's in there, so you end up starting to, again, connect the dots. So what can we do? What we ended up doing is building something that we think is an evolution where we can all run together instead of crawling or walking or just one team running. And the idea was, let's have a distributed but collaborative authorship of the data model. So there is a global single model, but different teams own different parts of it. And you build a single ORM-like layer which can auto-generate all the integrations that teams generally need when they are building a metadata service. So things that generally people need are, I want to do CRUD against a DB, I want to have search, and I want to be able to do relationship queries, traverse the graph of metadata. And finally, teams want to own their own destiny. So if I am the Kafka team, or I am the Hadoop team, and I'm running Hadoop and offering it as a service for the rest of the company, I want to also own that subgraph of metadata that I need to make my system run. So we wanted to make sure that we kept the opportunity for teams to own and operate their own services. So we're calling this the generalized metadata architecture. That's kind of something we came up with as a name. And this name has kind of stuck. People have actually understood it. Teams have said, OK, we get it. I'm going to attempt to explain it very quickly here today. You take a general metadata graph, and you try to model it using anchors. So you have your core entities, like a user or a person or a data set or a group, and you decide what are the main things that identify that one thing uniquely. And then you attach what we're calling aspects to those entities. So a data set can have an aspect called a schema. It can have another aspect called ownership. And these aspects can be modeled by teams differently. So a different team can model the ownership aspect, and a different team can own and model the schema aspect. Similarly, users and groups will have their own aspects. And then these aspects create relationships or imply relationships, or values in these aspects imply relationships. So on a data set, if I have an ownership of a particular person, that creates an owned by relationship, and so on and so forth. So that allows us, it's our attempt at doing a ER model for metadata. It allows us the kind of capabilities we wanted, the ability to have a single unambiguous name for things we care about, and then the ability for having ownership of subparts of the model and parceling it out to teams to own and even operate if they want to. So this is the logical model. Let me talk about the physicality of what it looks like. You take this model, and then using this model, you can stand up a service. That service provides API endpoints that are RESTful. LinkedIn actually built something called Pegasus and RESTly. They kind of go together in terms of the data model language, as well as the serving container. Both are open source. And so we ended up using that for our serving layer. And behind the serving layer that's hosting the API, there are helpers for developers of those services. So there's a CRUD DAO that allows you to do CRUD with your metadata model against a DB. And you could choose any document store, like either MySQL, or you could actually go with a full-fledged NoSQL document store like Espresso, which is what we run internally. Separately, there's a search DAO that allows you to hit the search index, and a graph DAO that allows you to hit the graph DB. And with these DAOs, you can actually build intelligent or good responders to your API endpoint. So you can host an endpoint that allows you to do CRUD. You can host endpoints that allow you to do search. So think of it more like a toolkit for metadata driven by a model. And this is how kind of the model integrates with the overall graph. So every time a new event or a new metadata element is getting changed, there's an audit event that gets emitted. And there are async processors integrating with it and populating the search index and the graph DB. So this is very similar to how LinkedIn's internal microservices architecture works, but these are all cookie-cutter things that can be auto-deployed. And so putting it all together, metadata is coming in from very different places. So you might have a team that wants to put all their metadata in Git right next to their code. You might have a team that builds a web app, and they want to collect metadata there. Maybe it's a dashboard where you're marking a particular dashboard as being certified, and that's a web app. And sometimes it could even be a service that is writing some data and wants to register some metadata. So all of these kind of integrations either go through Kafka, where you can publish a CRUD event, or they go directly over REST. Remember, I talked about us liking that duality, or the optionality of being able to write to Kafka or to REST. And then there are standardized event processors that are basically taking that model and then sending it to the appropriate service. So in this example, let's say I split up the model and said the dataset service is service A, and the users and the groups are in a different service, and different team owns and operates it. The event processor would basically route it to the appropriate service. And those services have their own source of truth DVs. They're also publishing events, which are then getting processed back into a global search index and a global graph, and that allows you to then have global visibility over the entire metadata graph. So that's kind of how it all comes together. And there's one last piece, which is these audit events are also getting pulled into Hadoop, just like every other data set. And then analytics and relevance can run on this data set using the metadata graph as the core data model. And when you do things like that, you can generate new metadata. So you can do things like, hey, you got your classification wrong because I did some analysis of the samples of the data, and I looked at your classification, and I think this should actually be a PII field. Or you can suggest new things like data sets you might be interested in, or other things that LinkedIn data science would like to build. So that creates new kinds of metadata that can then flow back into the global metadata graph. So that's kind of how we've all put it all together, all the way from creating metadata to flowing it all the way down into the lake and then using it to even create new metadata. All right, so if there's one slide as a builder that you want to take away from this talk, it is probably this one. It is, we had lots and lots of debates about how to build this. And we ended up doing, finally, a cheat sheet of what were the big decisions we made and why did we make them. So the first one that we had when we were designing a metadata system was, do we do generic types or specific? And to some extent, we were constrained or opinionated, you can call it either way, because LinkedIn really prefers strong types. And we like it because you can get auto-completion and a bunch of things in your compiler that you otherwise don't get. So we ended up preferring strong types that is layered on top of generic storage and supporting a model-first way of development where you describe your model first and then you code against it. The second thing we did was on our integration strategy. And this was sort of just the learnings from having evolved over the years. Do you go the crawling route, or do you do pub/sub, or do you do RESTful? And we ended up in a combined state with offering REST APIs for people who actually need read after write consistency, and also offering a Kafka route where you actually want decoupling. And sometimes, of course, the team has had to build crawlers. There are teams that say, well, we don't have time, and there's a use case to actually collect that metadata. So a team goes in and builds those crawlers, but then they actually publish into the bus instead of writing to the DB directly. And this, the final one, was actually the one that we spent the most time on, which was, do you do a single source of truth, where one metadata service to rule them all? Or do you do replicated, where you're aggregating everything into one? Or do you do federated, where there's still one, but it's kind of, it knows everything about everyone, and it's routing the queries to the appropriate places? And this answer, I don't know, it might be different depending on what phase you are in your maturity. Because we write a lot of code, and we were building new metadata systems pretty much every other quarter or month or year, we ended up going with the ORM approach as being our primary way of integrating. So for new metadata systems, just integrate as the ORM layer. Don't try to build something that then everyone has to integrate later. And if there are existing metadata systems that are hard to replace, like, oh, you got something off the shelf, and that's going to be there forever, then use Kafka to adapt. And the one thing around federated is that it's an easy way to get off the ground. For example, if I want to stand up a metadata service that does, I'm just thinking aloud here, maybe Hive and Kafka, right? And so you call it with a dataset name, and it's able to give you the schema for either a Hive table or a Kafka topic. It's pretty easy to build that service if all it does is turns around and calls the Hive metastore or the schema registry for Kafka. But it only supports lookup cases. And so when you want to now build search over all of these schemas, and if you want to build graph over kind of lineage and things like that, you anyway have to aggregate. So federation gets you off the ground, but it doesn't really help with the overall metadata problem. And then you must also be asking, well, there are 20 other metadata systems I've heard about. And so this slide is not about saying they are not great, but it's about describing what they do and how we think they do it and why they didn't exactly apply. So the Hive metastore is well known, but it's limited to Hadoop datasets generally. And it's also really optimized for kind of the query planning problem, and we were focused on something much larger. Apache Atlas, at least the model was generic, and we could produce strong types on top and make it work. It was definitely a contender for what we could build our metadata service on. Marquez is very new from WeWork. I think Willy's talking about it tomorrow. It also has kind of the strongly opinionated model, and it is focused on this problem, at least right now, of understanding how data pipelines work and getting the metadata from Airflow or any of these systems that are producing it, and just solving that one problem. Ground, I actually collaborated with Joe on this when he was working on this project. It has a lot of good ideas, but from a production code hardiness perspective, it's still a research prototype. And a Munson came out of Lyft recently, and I would kind of compare it somewhat to Warehouse in its first incarnation, where it's a web app with a front-end service. But the back end, it actually writes through to the Hive Metastore. And that, I think, it's a good way to get it started, but I think over time, you need more than just that. But the biggest thing about pretty much all of these approaches is these are monolithic services. So they are one thing, you install it, and it gives you a certain kind of metadata. Or you can use it to store all of your metadata. But we actually wanted to allow teams to own and operate their own metadata services and not have to get tied into one. So that was also kind of a big deal for us. So a few numbers. It's always good to talk about the fact that this is actually running at scale. We have many, many millions of data sets and thousands of metrics, features, and schemas. And as you can see, we've really taken this mapping of the data construct graph at LinkedIn into metadata pretty seriously. So we've gone and modeled all the nodes in the graph, and they're all in there as entities. And there are a lot of new relationships that we are now starting to create. So that relationship events number of 3 million a day, it's going to go up very soon and very fast. So OK, you have a metadata platform. What can you build with it? Right? So far, I've been talking about a generic ER model and a toolkit for building metadata services. But if you could build something like this, what can you do? So that's also a good question. The first thing, of course, you build is the reference web app, the killer app that sits on top of all of this metadata. And we internally call it Data Hub. Its external name might either stay Data Hub, or we might just keep calling it Warehouse. It's built on top of the same technology, but we significantly rewrote parts of it. In fact, pretty much all of it was rewritten. And it provides very similar capabilities, searching and discovering all our data constructs, finding relationships between them, lineage, data quality, being able to enrich metadata. So if you want to attach new metadata, you can do it in the web app. And there were some interesting parallels even in building that web app, because when I want to enable extensibility of the web app, a particular team wants a particular aspect modeled. How do we add new pages to this app in a multi-team environment without making it look just like a form builder, right? So there's some interesting challenges there that I don't have time to get into. And this is what it looks like. You basically log in, and then you can search for data sets. You've got your search facets on the left that allow you to drill down further. There was a lot of work done on ranking and relevance. I talked about some of it before. Figuring out what are the top data sets to surface. When you build a toy app, it's very easy. But when you're actually building it, when you have millions of data sets in your ecosystem, that gets very hard. There's also a way to browse if you know what you're doing and you kind of want to follow categorization of data sets. And on a single data sets page, there are a bunch of aspects that are modeled. You can look at the schema. You can request access to the data set. You can look at who owns it. You can provide compliance metadata. There's a bunch of things. And this is continuously evolving. We added recently a way to provide institutional knowledge for some of these data sets. And we also have Lineage. This is also evolving. It's coarse-grained Lineage right now, where you can kind of look at inputs and outputs, but you don't quite know what's happening inside. And that's something we're working on. But it's a good way for people to understand how things relate to each other, obviously. And this is an example of a metrics profile page, right? And it obviously looks different. It is inside a data set. It's a particular column in the data set, and it has different metadata around it. So every entity sort of gets its own page. But there are other things you can do with it. You can do data management with compliance. And I've talked about this in the past at different conferences, and metadata was always part of the story, not the whole story. So what we've done is the metadata platform essentially allows us to address every single data set and every aspect of it across all of our physical data stores. And on top of it, we have a data access layer that allows us to access all of this data in a standard way. We call it DALI at LinkedIn. And it's not open source. And then on top of it, we have a data integration framework that manages all of this data, the life cycle of all of this data, whether it needs to get ingested or replicated or deleted on schedule or fine-grained purged because someone, a member closed their account, right? Or if someone requests an export. So Apache Goblin is something is a project I work on as well. It has evolved to kind of add this metadata as something it uses to drive how it moves data or how it cleans data. And then finally, we've also hooked this up to this data access layer to all of our standard compute frameworks like Spark, Hive, Pig, and Presto, and Azkaban, which is our workflow scheduler. And so a lot of the application code that teams are writing sits on top of these standard frameworks. And these standard frameworks are now emitting operations metadata, like I did this, or I ran this and this worked, things like that. And all of that goes back into the metadata platform. So you can do all of your data lifecycle management work along with compliance, because if you have a standard data access layer, it can rewrite data for you, and if you have a standard data management layer, this same metadata can drive all of that. That's been a huge success, I think, strategically for having built it at the right time. And the operations I talked about that the frameworks are all emitting, that can be used to look at pipeline operations that you would want to do, like which days have been generated correctly, and maybe I want to restart a run and things like that. So it allows for really clear visibility into your entire data ecosystem's health very quickly without having to have different teams own different problem spaces. So we've done search and discovery beyond just data sets, so search and discovery for all data constructs, data management and access with compliance, operational monitoring, and we're starting to work on incremental compute. And something I didn't spend time on, but the AI world is also working on productive machine learning, as well as reproducibility and explainability for AI models and features. And all of that metadata is also being modeled in the same platform. And I think we're just getting started, because every new team I meet that is doing something interesting with either data or something interesting that's internal is creating and consuming metadata. And they're all kind of interesting use cases waiting to get onboarded. And the good news is that it's open source again. So we went through a phase where we were open source, and it was nice, and then we stopped kind of being fully open source, and then we're kind of back. So that we're very happy that we were able to take all of these improvements that we were able to make to the back end of Warehouse and kind of bring it back to the community. So the details are on the slide. It's in the GitHub project Warehouse, and it's on a branch right now because it's obviously not backwards compatible with the first release of Warehouse. So we'll probably switch master at some point soon and make this the official branch. And the capabilities that you get out of the box are the generic modeling layer that gives you CRUD on MySQL, gives you search on Elastic. And we're about to, we have this working internally. We're just not yet open sourced it, the graph capabilities on Neo4j. And the interfaces that you get for interacting with this metadata include obviously the RESTful service, but also the Data Hub web app. So not all of it, but parts of it have been open sourced. So different aspects, if you think of it that way. And then these generic event processors that can take the metadata events and generate derived writes to search indexes, graph indexes, things like that. And the model itself, we're not open sourcing the whole model yet. So right now, what you'll get are data sets and people. And so one way to think about it is, I actually have a picture of it on the next slide. And from an integrations perspective, you get integration with a bunch of data catalogs that are kind of popular, like the Hive world and the Kafka world and the JDBC world. And you also get integration with people. So that at least brings two of the most important entities in your world together. The data model itself was interesting. So LinkedIn has an internal data model, obviously, which is very detailed, and LinkedIn's take on what it thinks about different things. And so what we're doing is kind of piece by piece open sourcing the model, thinking about kind of how generic to make it and kind of putting it out there. So that's going to be an interesting challenge as we make further changes to our internal model. And other things that are coming next, we'll have obviously more entities show up. So jobs are going to show up very soon. So you'll be able to see, you'll be able to actually create new metadata about how your jobs are running or the entities themselves, and flows, which are, I guess, workflows for us. And then other aspects within existing entities like policies for replicating data or managing data, the Hive specification for a particular data set, things like that. And we also want to do fine-grained lineage. It's, the way we're going about it is by integrating with all systems that are Calcite compatible. Calcite is an open source SQL engine, parser, a lot of things combined. And we're using that as our common denominator for parsing as well as generating fine-grained lineage. And the app obviously is going to evolve. We're working already on user pages, so everyone gets a profile just like you do on LinkedIn, and you can have skills and other things on it. And then supporting social interactions so that you can actually have a conversation about the things that matter. And what we want from you guys is to get engaged and contribute to this global model. It's going to be an interesting exercise to figure out what is a global metadata model that everyone can agree about. And then build integrations with systems. So you might have systems that we don't have, and so get involved and build those integrations, and I think everyone will benefit. And that's my talk. Thank you. All right, thank you.
And I think we have time for 2 or 3 questions before you go. Just wait. Oh, well, happy birthday.
All right, thank you, thank you.
So from Lajos, graph databases are very popular these days, but all seems to have a trade-off. Which GraphDB is used at LinkedIn?
We obviously built our own. Yeah, so graph databases are popular for sure. We built our own distributed graph DB. We actually have a paper or two about it. It's called Liquid internally. And if you catch me offline, I can probably find you the paper so you can go read up about it. It's a pretty hard problem.
If there is a preference for strong types in code, why go for a schemaless DB? Was it performance related?
Yeah, so the preference for strong types is in the API layer, right? In how you write to the metadata system. But choosing a schemaless DB allows us to have schema evolution be pretty easy to do. So when we integrate with document stores, we are going to tell, document stores that like schemas, we are going to tell them about the schema. But for example, if you're integrating with MySQL, we only tell MySQL the stuff that we need to tell it for the indexes we want on the data. So that way, if someone adds a new column, that doesn't require an alter table and that kind of stuff.
30,000 metrics is a lot. How do you keep track of them?
So that's a great question. We ask this question ourselves a lot, too. The 30,000 number you see there, it leads to the question of what is a metric, right? And that's a whole different talk. But the way we think about them is that metrics are measures, and some metrics have dimensions attached to them because they've been computed a certain way, right? Members by, signups by country, by something in the last 7 days. For someone, that could be a metric. And so that ends up being kind of a big problem. The metadata platform is actually intending to solve this problem of why do we have 30,000 metrics, and do we need all of them or not, and kind of understanding the duplication where it exists and understanding where it was needed.
All right, and for the last one, have you analyzed the actual metadata, and have you found anything interesting?
So there's definitely different kinds of analysis we've done. The one that I talked about was related to refinements in the metadata. So we have a human cataloging process where people annotate data sets, and then we have a combination of ML as well as other things that go in and analyze that metadata and figure out what to suggest for some of these columns. I guess one interesting thing I can point out is oftentimes data owners don't know what they're putting in their data set, and that was interesting.
All right, that's all we have here, so thank you very much. One more round of applause.
Thank you.